on this, the first one, was the first one easy or hard? Easy. Fit one of the families, right?
Yep.
How long? If this side's 5, this leg's 5, this leg's 12. What's this leg? Or no,
13.
what's this hypotenuse?
13.
13.
Awesome.
If you did Pythagorean's theorem, would it still work out all right?
Sure.
Yeah. This one, this is 5, that's 12, that's 13, right?
No, 10.9.
This one you have to use Pythagorean's theorem. Tell me how to set up Pythagorean's theorem for this one.
12 squared minus
See,
5 squared plus c squared equals 12 squared.
I know Quentin doesn't ever believe me that he's going to mess up at some point when we do the harder problems, but then it always comes out on the test that hypotenuse over there, legs over here. What is 5 squared?
25.
25.
I ain't going to argue with Quentin about he wants to find the shorter way every time, and does that shorter way always work? And I had this discussion right before the last test. I got pretty irate about it. Usually I don't get too mad, but I got mad that day. Subtract 25, 119, now what?
Take the square root of it.
Square root of it. What's square root of 119? 10.9, everybody agree with that?
Yeah.
Quentin's good lower there going, see, I got the right answer. Is it always going to work? Apparently. We'll just
Yes.
let him go with what he's wanting to do, and I'm
I've
not
tried
gonna
it
argue
out
with
of every single
And
problem. It works.
Now, on this one. No
Don't
clue?
even deal with the radicals. Just put that on the end, and then take.
So-
Since this is a perfect square family, I mean, perfect.
It's a
It's a triple.
Pythagorean triple.
So
8, 15,
17.
17. So is this side just 17?
17 square root of 2.
17 times the square root of 2. Now, could we do Pythagorean's theorem on that?
Yeah, we could.
Watch, when you do Pythagorean's theorem, watch, because some of them won't come out that nice. I made this one to come out nice because it makes it easy for me to grade. This is how you would have to do this if you use Pythagorean's theorem. Watch closely and listen closely, because on next one, when we take a quiz next time, it won't be this easy. Those are our 2 legs. What's our hypotenuse this time?
C squared.
We don't know it, right? When I square this, watch closely on this. When I square this number, and then you square that. You got to square both of them. What's 15 squared? Grab your calculator.
225.
225. What happens with the square root of 2 and 2? What do those two do? Cancel out, and you're left with 2. So does that mean I have 2,252?
No, you got
You're multiplying those. What is 225 times 2?
450.
450. Do the same thing here. What's 8 squared?
64.
64. Times, what happens there? Just 2, right? What's 64 times 2? 128. What are we going to do with those two?
Add them together.
Add them together, you get 578. Then what do you have to do? Take the square root. Now, I didn't tell you which answer to give me on this, so if you grabbed your calculator and you took the square root of 578, gives you some decimal answer. Am I going to accept either one of them?
It was 24.
Yeah, 20.0 or something. Didn't come out even, did it? And I think it came out 24.02 or something. 041.
Oh yeah, I just found it.
All right, so I would probably accept either one of those 2 answers.
So
This one was easier because it fit that family. Lane's going to make sure, because he wasn't here last time, that he gets notes off somebody, because does Lane know the families? No.
I tried explaining them to him.
When you're rounding like numbers that have like 0.0 something, do you just want us to put points?
Yeah. And Trina brings up a good point. When you get something like this, 04, whatever it was on out there, and we know we're rounding off to the nearest 10th. I had this argument with my son last night because he had a problem like this on his homework, and he rounded it off to 24. And I said, that's wrong. Why is it
You need
wrong?
to add the .0.
You need the .0 because it's a significant digit. Sig figs in science class, have you dealt with that yet?
not yet.
So when you get to sig figs, that's what it's talking about. 24 is not the same as 24.0. Because if I put down 24, it looks like Tyler was trying to say, it looked like it came out what?
Full.
A whole number, even, nice and even. Did it? No. And that's why I put this on there, because that's a significant figure to tell everybody, hey, it didn't come out all nice and even. We rounded it off to the nearest 10. I know you talked about that in science class.
Oh,
Because
my
it was
God.
good. I did. Oh, you did. I didn't.
Where did you run off to this kind of
Trey
level?
took like 5 years in that.
The worksheet. Make sure your names are on those worksheets. I'm going to collect them here in just a minute. Questions.
35?
35.
18.0 centimeters.
Actually, that's 39, my bad.
39?
Yeah, 39. Yeah, 39, my bad.
39. The area of a square is 81 centimeters squared. Watch, because this is going to lead us into what we do today. And the stuff we do today, my other class thought, oh, that's real easy. And then they had a bunch of trouble with it. So we got this square. And we know that the area is 81 square or centimeters squared. From that, can anybody tell me how long each side is? Besides Mark.
No.
9. Why 9? The area of a square, we take length times width, right? Well, if they're the same, the only number it's going to give us 81 is 9 times 9. How long is this side then? How long is this side? We want to find the length of, what is that? Length of that diagonal, right? Does everybody remember what a diagonal is? We talked about that about 2 chapters ago and used it a whole bunch. So we want to find the length of that. That's a right angle because it was a square, right? So if I just split off, ignore that. That's 9, that's 9. This is the side we're looking for, right? Tell me how to set up Pythagorean's theorem.
9 squared plus 9 squared equals c squared.
What is 9 squared?
81.
It's 81 plus 81.
162.
Now what?
You do the square root.
Take square root of both sides.
12.7.
Now, today, when we do this problem today, I won't accept that answer. The reason, square root of 162. I wrote this list back up here again. I want the exact answer, not the rounded off answer. So remember, we got to go through this list, and we try to find a number. Have your calculators out so you can help me. We try to find one of these numbers that will divide evenly into 162.
81.
Does everybody agree with Mark?
He is right.
Is that the biggest one? Will 100 go in there even?
No.
121?
No.
144?
No.
169? Do I need
No.
to go any farther?
No.
So 81's the biggest? Remember,
Yes,
this is how you do this. This is how you break this down. You break it down 81 times, ignore that stray mark, 81 times what gives you 162? 2. What is the square root of 81?
9.
That's the exact answer. Now let's go back to this. I got this square here. Watch it how this is labeled. This is 9, that's 9. That diagonal is 9 times the square root of 2. Look at it for a minute. Now, give me this answer. I draw this square. This side is 12, this side's 12. How long is that diagonal? 12 times the square root of 2. That's what we're going to talk about today. That's one of the patterns. It's sort of like the families, where you can just pick up on the patterns. This side right here has got to be 12 times the square root of 2, or that diagonal's got to be 12 times the square root of 2. If I told you this room is a square. This is our room. It's 30 feet by 30 feet. How long is it from that corner to that corner? 30 times the square root of 2. On a softball field is a square. All right, a baseball field's a square also, not a diamond. It's a square. How far is it from first base to third base on a softball field? How far is this side? On a softball field? 60 feet. This side, 60. This side, how long is this from? 60 feet, or 60 times the square root of 2. We're going to talk about those today. Next problem. 43. 43, I'm not reading it, so I'm hoping Tyler's reading it because otherwise we're not doing it.
Okay.
You got Tommy the turtle right here. This is my turtle.
He's so cute.
He's got a tail there. He's walking, and they say he does what?
1.2 miles and turns around.
1.2 miles, and he comes to a
T.
T. Well, if that's a T, then that means this angle right here is a what? Right angle. And he turns to the right, so now he's going this way. What else they tell us?
1.6 miles that way.
So we got my giraffe here.
What is this?
I guess
It's
it works.
We got my giraffe there. And the giraffe's seen Tommy the turtle. How far was Tommy the turtle from the T? 1.6 miles? And what do they want to know? This is his pin back here where he started, right? So that's the distance we're looking for. Can we use Pythagorean theorem?
Yes, but you could also use the Pythagorean theorem's triplets.
1.2 what?
19.
1.2, tell me how to set it up. Squared plus 1.6 squared equals c squared. We do all that math right there, what's that give us?
2 miles.
I don't think it gives us 2. Somebody do all that math on their calculator.
2.0.
That don't sound right.
4.
4?
Oh, well, the final one.
Yeah.
No, I don't know what you mean. Take
Oh,
square root here,
I
square
think
root
you
there, what do you
answered.
come up with?
2.
2 miles.
Yeah. I gave the final answer.
2 miles. Now, does that fit one of the families?
Yeah. 3, 4, 5.
How does it fit the 3, 4, 5 family?
Because 12, 16.
0.4 times.
So you take each one of these times 0.4. Now, are most people going to figure out that that's times 0.4 on each one?
No.
Probably not. So probably the best way is to use Pythagorean theorem on that one, right? What's 0.4?
Yeah,
Grab your calculator. What's 0.4 times 3?
1.2.
1.2. What's 0.4 times 4? 1.6. Then we do 0.4 times 5. 2. Probably wouldn't figure that out, right?
33.
Which one?
33.
Scott wants to swim across the river. So we got this river here. We got this river here. Apparently it's 400 meters across. Scott starts, he's right here. Now what? What's it say? 'Cause
80
I'm-
meters to shore, but ends up 100 meters downriver from where he started because of the current.
So he ended up down here and he's 100 meters farther down. What do we know about this angle right here?
Right angle.
Right angle. And we're looking for how far he actually swam, right? Or how far he actually swam. Swam. What's our Pythagorean theorem? How would I set it up?
400 squared plus 100 squared.
Now you guys have picked me out a bunch of them that gave you both legs. Is it always going to give you both legs? No. If I do all that math. Well, I don't hear any buttons on the calculators.
Final answer? I did.
What is it?
I get the final.
I don't want to find. I want all that.
170,000.
Anybody else agree with that? Now what do we do?
40 squared root.
Take the square root of that. This is going to cancel out. Leave us with C.
412.3.
What'd they tell us? Read the problem again.
How far did he actually swim from his start?
Didn't tell us round it off anywhere or anything. So 412 point what?
31056.
Close enough. And that's meters, right?
Yeah.
So it makes sense for that side in that right triangle to be 412 meters. What should be true about that side in that triangle?
It should be the longest.
This should be the longest side. Did it come out to be the longest side? Next question.
I don't have it.
30.
30?
Yeah.
Mark didn't act like he was done. He was saying 30 and then. Problem 30. Two sides of a right triangle are 8 and 12. This has got a part A and a part B.
This is probably going to be his favorite.
Find the missing side if the two lengths are the legs. So this is 8, this is 12.
Yeah.
Can we find that one pretty easy?
Yeah.
Yeah, it fits in that family. What's that side going to be? Don't sound right. Or does it fit the family?
No.
Oh, it doesn't, does it?
No. Because it's 5 and 12, you
All
get
right.
13.
So it doesn't fit. So we have to do what here? Pythagorean theorem. 8 squared plus 12 squared equals c squared. Somebody do all that for me. 208. Then what do we do? X square root. 14.4. Does that make sense for that hypotenuse to be 14.4?
Yes.
Then they say that one of them's a leg, one of them's the hypotenuse. Well, if we got 8 and 12, which one's the hypotenuse? And then this one's 8, and we're looking for this other leg, right? So this time, how would I set it up? Plus b squared equals 144. Subtract 64 on both sides. Everybody watching closely on this because I'm not going to do this the way I've done all the rest of them. You end up with b squared equals what?
80.
80. Now watch because I want to make sure that you understand this. We did this on one of the other problems. We take the square root of both sides. I don't want the decimal answer this time. Square root of 80, I want the exact answer, not rounded off. So make sure you're watching closely so that you understand how to give the exact answer. Any of those perfect square numbers up there divide evenly into 80.
16.
16 wills. Everybody see how Mark got that? He probably grabbed his calculator and figured out that they divide evenly, right? Colton's
No, I know
upset
that as
because
a fast fact because 16 times 5.
Colton's upset because Mark can do it so quick in his head.
I wasn't even paying attention.
So you gotta make sure that you can do that. If I do this, 16 times what? 5. So you break it into those twos. Everybody seeing this? This is the way you gotta be able to do this. What is the square root of 16? Square root of 5, what do we do with that? Just leave it there. 4 times the square root of 5. That's an exact answer, not that crazy decimal answer. All right, make sure your names are on those, and you're going to lay them right here on this desk right behind Quentin. Once you do that, start copying this down that's on the board. If I can ever get to it. Copy all that. So 45, good thing I wasn't recording there, wasn't it? One of them, so 45, 45, 90 triangle. Why do you think it's called the 45, 45, 90 triangle?
2 angles are 45 degrees.
You got 2 angles that are 45 degrees and the other one's 90 degrees.
And they're 45 rather than 90.
If I know that I have a 45, 45, 90 triangle, not only are those 2 angles the same, what else do I know in that triangle? It's got a right angle. What else? It's isosceles. The 2 sides across from those angles. If the angles are the same, the sides across from them have to be the same. We had that isosceles triangle theorem a while back, right? So what do we know about this side and this side? Stupid thing. They got to be the same, right? I'm going to put something up here in a minute to show you all this, but I want to run through this first. The 2 legs are always congruent to each other. The hypotenuse is always whatever the length of the leg is times the square root of 2. This is the very first thing I want you to do every single time. Some of these, and it's going to seem tedious to do it because some of them are going to be real easy. Alright? But then the harder ones, it's going to make more sense to do it. But if you do it every time, then it's going to make everything a little easier. After you do that, you're going to have to set up an equation. Now we're going to talk about another special kind of triangle, and it's the same deal. Label it first. Always label it first. Alright? For the rest of this chapter, every triangle we deal with, we're going to label the sides very first thing. That's what I want you to be able to do, Quentin. Label the sides. You got to know to label the sides every single time. A lot of books use X. I usually use this. It's a cursive lowercase l. This time I used X. How come I probably wouldn't use X? This is the first year I've ever taught it this way.
Multiplication problems.
Nah, I hope not, because by now you should know that multiplication is what?
Dot.
A dot.
Dot.
How come I wouldn't use X? When you see a problem, problem number 2 in the book, on your homework, what's the variable they're going to have right there? X. And that's going to confuse everything. Because I'm telling you to label it with X, and they already have an X on a different side. Alright, so you got to make sure that that doesn't confuse you. You're going to label this every time. Notice here, first thing I did, side across from the 45-degree angle. I'm going to label that side X. Should write all this down. This right here that we're doing right here, all of this is the important stuff. Guess what the side across from the other 45-degree angle is going to be labeled? Same thing, X. The side across from the right angle. By drawing that arrow, that hypotenuse over there, guess what it's going to be labeled? You don't know, and that's what I'm going to show you.
X, the square root of 2.
X times the square root of 2. We just got done doing several of those when I showed you that pattern, right? And that's the pattern right there. So if I gave you a triangle, and this triangle is a 45, 45, 90 triangle, and I told you this side over here was 7. That side's going to be labeled X. That side's going to be labeled X. That side's going to be labeled X times the square root of 2. We look at this right here, and what you're going to do every single time is set up an equation. Now some of these equations are going to be really, really easy, and Lane's going to like them. And this is one of them. The equation you set up is what you wrote down and what they told you, the side that you know both things on, you just set up that as an equation. So this time my equation is just X equals 7. Is there anything to solve there? Nope. So from here on out we know that X equals what? 7. So when I look back over here in place of X right there, what can I stick in? 7. That's the length of that side. How long is this hypotenuse?
7 is the square root of 2.
7 times the square root of 2. Now that's easy when they give you what? One of the 2 legs. And that's what, next thing I want you to write down, I'm going to erase this real quick, because I want you to write down 2 more things on this. Easy. And then we're going to write hard. It's easy when given what? Leg. When given a leg. When do you think it's going to turn out to be hard? When given, what's the other side called? It's not a leg. When given a hypotenuse. When you're given a hypotenuse, it makes it much more difficult. Because Quentin's going to say, well, you told us that side was 7, that's easy. That side's 7, that side's 7 radical 2. And he's right. But as soon as I do this, get rid of that, and I tell you this side over here is 10. Is it so easy anymore? Does it mean this side's 10 and that side's 10? Doesn't work that way. You're going to have to set up an equation, and it's going to be X times the square root of 2 equals 10. You're going to have to solve for X. Alright? And we're going to do some of that here in just a minute. Okay? It's probably not going to be easy, right? Because I can tell by looking Teresa's face, she knows that I'm not gonna let her just divide by 1.4, whatever the square root of 2 is, and get away with the decimal answer, because it's not gonna happen.
No, that would be a wrong answer.
Wouldn't be wrong, it just wouldn't be the answer I want. Does everybody understand that then? What's the first thing you're gonna make sure you do anytime you see a 45, 45, 90 triangle? Label it x, x, x radical 2, every single time. Alright?
Would be.
Write this down, a square. If you're given a square and you draw a diagonal in that square, guess what kind of triangles you have? Right isosceles, 45, 45, 90 triangles. Both of them. So I have this square here. How do I know that's a square? All four sides are congruent and it has a right angle. So all four sides are congruent, that makes it a rhombus. It's got one right angle, that makes it a rectangle. If it's both a rectangle and a rhombus, then we know it's a square. Hey, that's something we did a couple chapters ago, isn't it? So we know that that's a square. If I draw in that diagonal right there, guess what kind of triangle this top triangle is? 45, 45, 90. Guess what kind of triangle the bottom triangle is? 45, 45, 90. So anytime you have a square and you draw in a diagonal, you're forming 45, 45, 90 triangles. So all that stuff we talked about on the last slide works. So when we were just talking about a softball field a second ago, and I knew that this side was 60, this side was 60, this side was 60, and I said, okay, we want to go first to third. I want to throw the ball from first base to third base. I knew, hey, these are 45, 45, 90 triangles, so this side right here has got to be 60 times the square root of 2. Link that diagonal. Man, it's getting all this by osmosis. You ever seen them when at night, you put on the headphones and you listen to like Spanish or something so you can learn it? That's probably too old for you guys. When I was growing up, it was a big deal that they said, oh, you can learn while you're sleeping. And they buy a tape and listen to it all night long, and you're supposed to learn it, and then everybody figured out that it doesn't work. They figured out it didn't work. Yeah, it would.
Just keep me awake.
Keep me awake too. I wouldn't do that. So anytime you have a square, as soon as you see any of these problems that we do for the next few days, you see it's a square. What kind of triangle are you going to think of? 45, 45, 90, a right isosceles triangle. All right? So first words. In a square. This is problem number 10 on the homework. Right away, what are you going to think of? 45, 45, 90. What if I drew another diagonal in here? Guess what kind of triangle this one over here is?
45, 45, 90.
45, 45, 90. How about this one? All of them, right? Because what do we know about the diagonals of a square here in the middle?
Right
They
angles.
form right angles. And this angle's got to be 45. That angle's 45. It's just a smaller 45, 45, 90 triangle. Now it's a smaller 45, 45, 90 triangle. Instead of the diagonal being the hypotenuse, now the length of the side's the hypotenuse. Why? Next, 30, 60, 90. This is the other kind of triangle. Again, look at the first thing right here. What's it say you're going to do? Label it. So before you start writing everything down, I'm going to show you how to label a 30, 60, 90 triangle. Put all this motion in here. I need to use it. Side across from the 30-degree angle. Drawing that arrow, side across from the 30-degree angle is always going to be labeled X. Side across from the 60-degree angle is always going to be labeled X times the square root of 3. Is somebody going to get the square root of 3 and the square root of 2 confused from the other side? Probably so. Just something you gotta remember. Side across from the right angle is gonna always be labeled 2x. First thing you're gonna do, you see a 30, 60, 90 triangle, label those three sides. I'll give you a minute to write that down. Holly, what'd you do? Make Valerie sick, so she had to go home. You know, I'm just lying. It's not you that made her sick. It's probably me. So.
Yeah, she's probably scared of you now.
Huh?
She's probably scared of you now.
I didn't even know she was gone.
She was last class.
Is it assignment in class?
Michael, do me a favor. Put your name on this. And then keep this. I'm such a scary person. Did you figure out anything about your other grades?
Yeah. She said they're down there if you need to see them, and I can write them down for you.
See, I'm not even gonna make a comment. I'm just gonna keep my mouth shut and take the high road and not be a jerk this time. You know, the one they signed? Yeah, the one. Which question, Mark?
What is my final grade, including my homework that I turned in?
It's on there, no, it's not on moving that, because I
Yeah.
changed over to the 4th weeks. You'll find out in a couple days, I guess, when the report cards come out.
Okay.
I don't know, I could look it up maybe here in a few minutes if. So first thing you're gonna do, you're gonna label them every time, just like with the 45, 45, 90 triangle. Then you're gonna have to set up an equation. I wanna do the same thing on this one. Let's write easy and hard. Which side's gonna be easy if they give us that side? Side across from what?
30.
The 30-degree angle. Side across from 30-degree angle. If they give us the side across from the 30-degree angle, where X is, it's going to be a pretty easy problem to solve. When's it going to be hard?
That's across from 60.
Side across from the 60-degree angle. When they give you the side across from the 60-degree angle, when they tell you that this side over here is 17, yeah, it's not going to be an easy problem. And we're gonna do stuff like that. Then this still applies. Set up an equation. If I told you that side right there was 17, all you're going to do to set up that equation, what you're supposed to label it equals what they told you the length of it was. So it'd be x times the square root of 3 equals 17. And then we're going to solve for x, and I'm going to show you how to do that here in a couple minutes. Those are going to be the hard ones when you have to do something like that. Does that mean you should just skip over those? No, because if you do that on the test, you're going to get about a 40. Because I'm going to put about 40% easy problems, 60% the harder problems. Next, what's an equilateral triangle? All sides are equal. In this equilateral triangle, if I draw an altitude, anybody remember what an altitude is?
It's a line segment going from one of the vertexes straight down to the middle of the other side.
Forms what?
A right angle with.
Forms right angles. Now it actually does bisect it if it's an equilateral triangle, but an altitude, just knowing the word altitude, altitude always means it comes together and forms a right angle. Okay? So if I draw that in, that's an altitude. What can you tell me about this angle right here in this equilateral
60
triangle?
degrees.
60 degrees. How about this angle?
60 degrees.
Now when I draw in that altitude, guess what it does to this top angle?
Bisects.
Splits it in half. So how much is each one of those?
30 degrees, 30 degrees.
30 degrees, 30 degrees. What kind of triangles are both these triangles?
30, 60, 90.
30, 60, 90. Same as we were just talking about on the other side. So if you got an equilateral triangle, and you draw in an altitude in that equilateral triangle, then it's going to form two 30, 60, 90 triangles. And we can use all that stuff. And this one, what should this be labeled? Side across from the 30 degree angle.
X.
X, side across from the 60 degree angle, which is the
X.
altitude.
X the square root of 2.
X
Three.
square root
I mean
of
3.
3. See, Mark confused them already. Side across from the right angle,
2x.
2x. What should this side over here be labeled?
2x.
2x this side,
X.
x. That side we already got labeled, right? I don't think I have anything. I'm a king.
I do.
Oh, you have food? Maybe if I was a nice guy, I'd eat something.
I'm trying to agree.
Easy stuff, Dakota. Can handle it all. Good with patterns. Go home each day. Mom meets you at the door and punches you in the nose. After about 5 days, you probably, what? Use a different door, right? Or dodge, open the door, and
Hit her
stand
back.
back here, hit her back. I'll remember that one.
Take her out
When
with some
mom
karate.
calls me,
Just kidding, my mom would like kill me if I tried to punch her back.
when mom calls me, Trina, I'm gonna remember that. So you better make sure, because you know if she sees that grade, you'll be like, she's gonna call me. So you better make sure you get that stuff into me early tomorrow. Because you don't want me telling her, well, yeah, we were talking about what happens if mom punches you in the nose, and she said she was gonna hit you back. Draw these 4 triangles. We're going to work them together. These are the easy problems. Easy problems. Then we'll do the hard ones on the next slide. We want to hurry up and get through this because Tyler would enjoy it so much if on this worksheet that he's got to do that we work some problems together and get part of it done. Make sure you skip a little space in between them, spread them out somehow on your paper so you can do your work there. It doesn't do any good for you to write down examples if you don't work them out there and see how you did it. Always kills me. I look at some of your notebooks and I see 3x plus 5 minus 2x plus 4 equals 82. And then I don't see nothing else till it says x equals 3. And I think, why did you bother to write that down? Because it does you no good to see the problem and the answer if you don't know what's in between.
So I do my homework.
Homework, I mean, look looked at it that close, Colton, so his homework's like practice, right? I didn't come watch basketball practice or baseball practice or football practice. Come to watch the game. That shows me what you've been doing in practice. If you look like crap during the game, then that tells me you're probably screwing off in practice. In this first one, what kind of triangle we got? 45, 45, 90. What's this side going to be labeled? This side. This side.
No, x by the square, times square root of 2.
That's the side we know. What's the equation we can set up? Easy one. X equals 7. Everywhere we see it, x, then we can stick what in its place? How long is this side? How long is this side? Pretty easy when they tell you one of the legs, as long as it's a whole number. Next one, what's this side going to be labeled? This side? This side? It's always labeled the same. X times the square root of 2. That's the side they told us this time, so what's my equation going to be? X times the square root of 2 equals what? 6 times the square root of 2. How do I get x by itself?
Cancel out the square root of 2's.
Divide both sides by the square root of 2. Divide that side, divide this side. Over here they cancel out. You're left with just x. Guess what happens over here? Cancel out and you're left with what? So x equals 6. How long is this side then? 6. How long is this side? 6.
So in that case, it is actually 6.
That one's pretty easy, right? And that one was pretty easy because they gave you the square root of 2 right there. We're going to do some on the next slide that's a little harder. Okay? This angle's 60. What's this angle? 30. In the 30, 60, 90 triangle, side across from the 30-degree angle should be labeled what? X. Side across from the 60-degree angle should be right there on your notes. X times the square root of 3. Side across from the right angle, 2x. Make sure you don't get those two confused. A lot of people mix those up. What's the equation we can set up? X equals 4. Nothing to solve here. Just know x is 4. If x is 4, how long is this bottom side? 4 times the square root of 3. That's one of our answers. How long is this side? 2 times 4, which is 8. Pretty easy if they give you that side. Next one, what's this angle? Side across from the 30-degree angle should be labeled what? Side across from the 60-degree angle? X times the square root of 3. Side across from the right angle? What equation we going to set up here? 2x equals 18. 2x equals 18. How do we solve for x? Divide by 2. X equals 9. How long is this side over here? 9. That's one of our answers. How long is this bottom side? 9 times the square root of 3. That's our second answer. Do we want to change that 9 times the square root of 3 into a decimal form? Why? This makes more work, right? Pretty easy ones there. Now you ready, Colton? No? Alright, so we'll wait. Tell me when you're ready. What's he doing? Quentin's wasting your time right now. Don't we freaking do it?
For like 3 times.
Oh. I thought you meant go for it and wait. Write these 4 down. A little tougher this time. Later on in the chapter, they're gonna ask you to solve the triangle. Anybody have a guess as to what solving a triangle involves?
Answer all the
Finding all the sides and all the angles. That's what we're doing right here. We're doing the same thing. So when we get to that, don't let it confuse you. Might make sure you got a little extra space on these. These take a little more work than the others. It's really itching bad. Might have to stick my finger in there. On the first one, what's this angle? 45. Good. Side across from the 45-degree angle. X. Side across from the other 45-degree angle. Side across from the right angle. X times square root of 2. A little tougher here. What's the equation we set up? Now watch closely on this. You're going to see how to do this. It's not really hard. I'm making it out to be all real hard, and it's not. The answer I don't want a decimal answer. All right? Sometimes you might want a decimal answer, and I'll be fine with that, and we'll talk about that as we go through these. How do I get x by itself? Divide by the square root of 2. These over here cancel out. On the other side, we got 46 divided by the square root of 2. You can't put those two together because one's a radical and one's a regular number. We talked a little about this when we talked about radicals a week or so ago. What you do, you got to get that radical out of the denominator. It can't be there. That's not a proper form. So we multiply the top by the square root of 2. Well, if we multiply the top by the square root of 2, what do we got to multiply the bottom by? Square root of 2. Same thing. Because what is square root of 2 over square root of 2?
1.
1. So are we changing anything when we multiply by 1? Now what happens here when you do this? You end up with 46 times the square root of 2 on top. And you might be able to see this pattern here and just use the pattern from here on out and not have to do a whole bunch of work. But you got to be careful because the pattern doesn't always work out the way you think it's going to. 46 times square root on top, of 2 on top. What is the square root of 2 times the square root of 2 that we have on bottom?
Square root of 4.
Square root of 4. Well, what is the square root of 4?
2.
2. Did we get the radical out of the denominator? Yeah, it's gone. Now, guess what we can do with this 2 and this 46? Divide it. What do you come up with? 23 times the square root of 2. What's left on bottom? Nothing. So we're left with x equals 23 radical 2. How long is this side? 23 radical 2. How long is this side? 23 radical 2.
So you just go
Sort of. Yeah, you take half
for half and then half.
and add the radical 2. Let's see if that works on this one. That won't. What's this angle?
7.5.
Now we're not going to do what Mark says. That 7.5, we're not even going to talk about that because if you got radicals and you got decimals, why not change the radical into a decimal and just do all decimals? We don't want to mix the two, right? Just like with fractions and decimals. You want to put a decimal in a fraction? That doesn't make any sense. Why not change it all to decimals? Side across from the 45-degree angles are going to be labeled what? XX. Side across from the right angle? X times the square root of 2. What's the equation we're going to set up this time? X times square root of 2 equals 15. What do I do first? Divide by the square root of 2. These cancel out. You're left with x equals 15. Divide by the square root of 2. You're gonna times top and bottom both by what? Square root of 2. You're doing the same thing over and over and over again, right? On top, we end up with what? 15 times square root of 2. On bottom, square root of 4, which is just 2. Bad thing this time, will 2 go into 15 evenly? No. So we leave it that way. How long is this side? When you get to Mr. A's class, you're going to see a lot of answers like this. Some of the time, you could go ahead and change that into a decimal. If it's some crazy one. And then when we get to this bottom one, the last one down here, this one's going to be sort of a crazy one. We're probably going to change it to just a decimal. All right? And I'll show you why. What's this angle? Side across from the 30-degree angle is labeled what? Side across from the 60-degree angle?
X to square root of 3.
Side across from the right angle? What's sorry? Shoot. Should erase some of this.
Why you're just going to circle?
Can you do that?
Yeah, and click middle. I don't have a bigger
Little
circle. You have to be circle.
No, that only works on the Mimeo.
Good enough. What's our equation going to be this time? Guess what we divide by this time? Pretty easy stuff, right? X equals, we can go ahead and do this up here. What are you going to multiply top and bottom both by? You can probably start figuring some of this out and skipping a whole bunch of these steps. What's left on bottom? It's just 3, right? 9 times square root of 3 on top. What are you going to be able to do with that 9 and that 3? Divide. 3 will go into 3 once. 3 will go into 9. How many times? Did I do all that too much? Confuse everybody? What's the final X here? Okay, so let's go back. Forget I did all that. So on top you got 9 times the square root of 3. On bottom, what's square root of 3 times square root of 3? Square root of 9. What is the square root of 9? So we got 9 times square root of 3 over 3. What can you do with this 3 and that 9? 3 will go into 3 once, 3 will go into 9. So what are you left with? 3 times the square root of 3. How long is this side then? 3 radical 3. Now here's where you got to be careful on this one. 2 times that. So we do 2 times 3 radical 3. All you do is multiply the 2 regular numbers. So 6 times the square root of 3. Don't multiply the number inside the radical times it. It's like doing this, Lane. Lane, you remember last year in algebra? If I told you this, 4x times 3. You only multiply the 3 and the 4, and you get 12x. You don't multiply the 3 times the x, right? Because it's already being multiplied in that. Same thing here. You just multiply the 2 times the 3. Don't worry about the thing inside. Last one, this is probably the toughest one. And we'll come up here and do it. What's this angle? That side? That side? That side? Same thing over and over again. Labeling these and then doing all this work. Equation. Divide both sides by. Multiply top and bottom by. On top we end up with 11 radical 3. On bottom, square root of 3 times square root of 3 is square root of 9. What is square root of 9? Will 3 go into 11 evenly? look what we can do. This 3 and that 3, guess what we can do with them? Absolutely nothing. I was just messing with you. You can't, because they're two different things, right? Sorry, Allie, I was trying to be a comedian and I probably shouldn't have been. So what's x equal? Equals that. That's ugly. You're probably never ever going to have 11 radical 3 over 3. So when you get something like that, that's that ugly,
Probably do something.
I probably wouldn't mind if you went ahead and grabbed your calculator and changed it to a decimal form.
Oh,
Alright, so you could have way back here, if you knew it was going to come out all ugly like that, you probably could have just took 11 divided by the square root of 3 and did the decimal. Now that other one that we came up with that was 15 radical 2 over 2, you don't want to change that to a decimal. Because you're going to deal with the unit circle next year, and there's a spot on the unit circle that's 15 radical 2 over 2, and you need to know where that spot is. Alright? So some of these you want to change, some of them you don't. Does that make any sense? And I know you don't.
What ones do you know?
You don't. Yeah. So if you leave it this way, I'm probably not going to throw a big fit. If it's some crazy number like 151 times the square root of 3 over 3, yeah, I would probably go ahead and change that to a decimal. Because that's just completely and totally ridiculous, and you're never going to see that. Do what? And we're getting ready to do it. So now I know this side is how much? That right there, right? 11 radical 3 over 3. How do I find this side? Times that. Now, do I multiply the bottom by 2 also?
No.
No, just the top. So what's this come out to be?
22 radical 3 over.
What about you multiply?
When you multiply this, if I did this, Colton, 3/4, if I take 3/4 times 3, you put that 3 over a 1 and you just multiply straight across, right? So it's 9 over 4. Same idea here. When you multiply 11 radical 3 over 3 times 2, you put a 1 underneath that and you just multiply tops, multiply bottoms. Does that make sense?
Yeah, I just get the mix up. When you calculate.
Yeah, don't, yeah. There's, remember me saying when we did the proportions that there's actually no such thing as cross multiplying anywhere in math. That's just some made up thing that they made up to make it easier on you back in 5th or 6th grade whenever you did that. All right, there shouldn't be any such thing as cross multiplying. I forgot about these. How long is diagonal of a square? You don't have to write these down. Let's just run through them real quick. If the length of a side is 32, so if this side's 32, how long is this diagonal? How could we find that out?
32 to the square root of 2.
32 times the square root of 2. You can probably figure that out without doing a whole lot of work, right? Because what kind of triangles are both those triangles?
45.
45, 45, 90, isosceles right. What is the area of a square with a diagonal that's 12? So we got this square, this diagonal's 12. We want to know the area. That side, that diagonal should be labeled what in that square? This side's x, that side's x. What's that side?
X to the square root of 2.
X times the square root of 2. Somebody help me out with the calculator. Let's change this into a decimal. What do I got to do to get x by itself? Divide by the square root of 2. Just tell me what x is as a decimal. Close enough.
85.
How long is this side in this square then? 8.4. How long is this side? 8.4. How do we find the area of it? Length times width, right? So somebody help me out. What's 8.4 times 8.4? 70.6. What's our units? Inches squared. Next one, yield sign. Does it actually look like that? What kind of triangle is a yield sign? Equilateral. So in this, what I'm going to have to do is I'm going to have to draw this. What is that? What is it? It's an altitude. So we got that altitude in there. When I draw that altitude, let's measure this angle right here. Let's measure this angle. 30. So what kind of triangle do we have here? 30, 60, 90. We want to find the area of the sine. What's the formula for area of a triangle? Half base times height. We already know the base. What is the base? 36. All we need to find is the height. The height is that right there. If this, how long is this part right here? 18. That's the side across from the 30-degree angle that should be labeled x. So what's x equal? 18. Side across from the 60-degree angle should be x times the square root of 3. What goes in place of x right there? Somebody help me out. What's 18 times the square root of 3? That's going to give us the height.
31.18.
So 31.2. How are we going to find the area? Multiply those. Somebody help me out and do all that. 0.5 times 36 times 31.2.
561.46.
What's our units?
Inches.
Just inches? Go out on the road tonight and you see a yield sign. Guess what the area of it is? Nobody needs to know that? I got in trouble once when I was...
Yeah.
Yep. Was it wrong?
The square area would have been 72.
72?
Yep.
If we did it exactly?
Yes.
So if we wouldn't have rounded it off with the decimal, it would have been exact.
Yeah.
Oh. I needed that.
Minus 5. I know I'm trying to find, we have to be here at 6.
That's a good thing about being a robot myself. I don't have to do anybody.
You get out of it.